Hi, my name is Clint Wyckoff and I lead tech marketing here at Nebulon. In today's VMUG virtual session, we're going to focus on architecting a self-service infrastructure for your VMware deployment. This session is pre-recorded. I am, however, online with you live to take questions and answers, so please, throughout the session, feel free to engage. I'm here with you live. I have sprinkled in a mix of diagramming, slides, and demonstration. At the end of this session, you're going to walk away with a solid understanding of A, what self-service infrastructure means, and B, how Nebulon cloud-defined storage fits into a self-service VMware environment. So all the buzz in the IT world is around cloud. Hyperscale, public, hybrid, SaaS, you name it. There is a mix of cloud everywhere. But why? Have you ever actually sat back and asked yourself, why are companies adopting the cloud? What's all the buzz about? Well, for one, it's because the cloud is easy. It is the easy button. I can go throw down a credit card and be up and running quickly. No need to wait for ITSM tickets to get completed after weeks and possibly months of time. Two, you only pay for what you use. You may have heard of the term utility computing. Well, this refers to only paying for what you use, and it's on and off as needed. Three, it is easy. I sort of mentioned that earlier, but what if we could offer project teams, developers, app owners a similar experience only on premises? The benefits here are really intriguing. You already own the data center or have a lease on the colo space. We have a long-term depreciation on our already purchased hardware. Gets pretty interesting quickly. Lastly, with on-prem, I would argue that it is quite easier to control security access of your data and also the access controls and who can see what and get where, right? So with this being said, why do organizations continue to struggle to offer that cloud-like experience inside of their on-premises environment? Well, for one, the infrastructure owned does not make it easy, meaning that it was not built with automation, SDKs, or APIs in mind. Secondly, project teams lack operation experience. This is worth a larger discussion in how to build an agile project team with a mix of skill sets, but for the most part, this remains very true for the vast majority of the companies I have worked with in recent time. Code, code, code. Infrastructure is code increasing in popularity, and it can be quite intimidating to learn something new and step outside of your normal comfort zone. However, whether this is through the likes of Ansible or Terraform or even just running Python to automate tasks, the benefits are extreme when it comes to a template-style approach of delivering IT resources, and this is definitely not something that infrastructure and operation folks have used, at least at scale, traditionally. Lastly, bringing forth the utility-style consumption model on premises will make better use of resources. For one, if they're not used, you can power them off instead of spinning idle, wasting resources. Secondly, they can be provisioned and re-provisioned repeatedly, dependent upon the project or the workload. So how does this relate to what we have been building at Nebulon? Cloud-defined storage offers an interesting cloud-managed approach to delivering storage to your mission-critical applications. Cloud-defined storage separates the storage control and management plane and places it in the cloud. We call this Nebulon On. Nebulon On offers customers many unique SaaS-type benefits, like frequent updates, ease of management at scale, and the power of the cloud to perform data analytics, which customers are able to benefit from in the form of intelligent recommendations. The data plane for your applications run directly on premises inside of the application servers themselves. The data plane is delivered inside of your app servers as a scale-out enterprise IoT device, which we call a Services Processing Unit, or SPU for short. This SPU is equipped with a 3 GHz 8-core processor. It's full height, full length PCIe card, and it runs all storage operations: compression, dedupe, erasure coding, and encryption. The fact that the storage processing is being conducted on the SPU means that your applications, virtual machines, operating systems, container pods, they all have access to all of your server resources in a scale-out fashion. There's no controller VMs, VIB packages to deploy on the host. If you purchase Intel Gold CPUs with 384 gigs of RAM, your VMs benefit from every single bit of all those CPU cores and memory that you purchased. Application servers in the cluster are all equipped with SPUs at the time of purchase. It's not an after-the-fact science project. In the example today, we'll build a vSphere cluster. But this could be a Kubernetes cluster, a database environment, any application of your choice which requires CPU, memory, and storage. Pretty much all. Let's dig into this further. In the diagram here, we have two sets of application servers, one on the far left and one on the far right. Each of these application servers contain local SSD as well as a Nebulon services processing unit. The SPU here connects to the physical drives in the servers via the server backplane and presents to the application's block storage. The cluster of application servers is what we call an MPod. These servers are network connected with dual 10 or 25 gig data interfaces, and the cloud management is achieved via a 1 gig control interface. The vast majority of updates are delivered much like a Gmail or Microsoft 365 experience. This is all done via Nebulon On without you, the customer, ever being aware. I mentioned earlier SaaS benefits. The cloud offers simple fleet management of the on-premises data plane. When was the last time you realized that your smart thermostat firmware was being updated? Likely never. However, you as a customer do control when updates are applied, but the same premise applies. The on-prem data plane is equivalent to an IoT endpoint device and is managed as such. Now that we've laid the foundation items of cloud-defined storage and you have a good understanding here, we're ready to introduce self-service into the mix. Cloud-defined storage is built from the ground up with an API-first mindset. This means, first off, everything we've created began with an API first, and then the UI was built. Anything I'm going to demo for you here momentarily via the Nebulon On user interface can be done via API or our SDKs. Second of all, the artifacts provisioned in cloud-defined storage are done so by using a template. Project teams, app owners, whomever is looking to provision storage or servers is able to choose from the curated list and get up and running quickly. Nebulon application templates provided are a default curated list, and you as a customer are able to take these templates and further customize them based on your organizational needs and best practices. This ensures that your storage and compute artifacts are provisioned following your corporate standard in a very reliable and repeatable fashion. In the example today, we're going to focus on our VMware template, which will provision ESXi, the necessary data stores, and get everything up and running for our application. So let's jump into that demo. Cloud-defined storage places the storage control and management plane in the cloud. The product ships with full role-based access controls like you would be used to utilizing in other public cloud providers. Here I'm going to log in today as a super user with full administrative rights to my organization. Each customer has their own unique Nebulon organization, as this is the multi-tenant boundary that you may be used to like an AWS organization or an Azure subscription, for example. Upon login, I'm presented with the overview section of my Nebulon-powered infrastructure. This is the default view, and it displays groups of applications. If you recall from earlier in the discussion, I mentioned the concept of an NPod. This is my application cluster, and today my NPod is going to be a vSphere cluster. Groups of NPods are called NPod groups. For example, in my lab environment here today, I have SMC3, SMC2, and SMC1. These may very well be lines of business, like marketing, SQA, and engineering, for example. These groups line up with my vCenter environment where I have my clusters named accordingly. The overview section displays critical performance information for my NPod groups. I have quick access to throughput, IOPS, and latency for all of my cloud-defined storage deployments within this individual NPod group. I also have access to critical capacity information. In a previous life, I was an IT pro, and capacity planning of the environment was complex, cumbersome, and immediately out of date. Nebulon On is applying machine learning against historical performance and capacity information to determine when your environment will be short on resources. We bubble this up through the user interface as well as via our alerting mechanisms. Now I'm going to aggregate the view differently. I'm going to shift from NPod groups to a more granular viewpoint, being my individual applications, or NPods as we call them. Here we can easily drill into a pod to view detailed performance and detailed capacity information. The increase in capacity utilization is seen here as I built this demo environment. The difference between the green line and the purple line is the effectiveness of cloud-defined storage's compression and deduplication, our data reduction technologies. Here my pod is getting 3.2 to 1 data reduction. What if my ops team or my product owner wanted to view more detailed and application specific information? Cloud defined storage is optionally able to pull performance and telemetry data from your vCenter infrastructure. Here in my lab environment, we can see the total virtual machine count, as well as the total CPU and memory consumed within the cluster, and the storage performance also. So let's shift the view from detailing statistical type performance related information over to actually performing administrative tasks. Within the admin section of Nebulon On, I'm able to provision new pods, create snapshot schedules, or create and edit configuration templates. Nebulon provides a curated list of default templates which are based on cloud-defined storage best practices for each application. These curated templates will be based on common operating systems, and we're able to clone these and customize them to meet your application or your environmental needs. Here in this example, I'll click on my Linux bootlunds template. Whenever this template is applied, all servers in the pod will provision a bootlun based on the operating system image, and they will also have data storage volumes which are able to be mounted and used as application storage. Configuration templates also include a volume-based snapshot schedule. This allows you to quickly and easily clone, mount, and export snapshots to host within the cluster. This is good for recovery purposes. So here I have my, click over here, my MPods, this one here, so we'll pick on this guy really quickly. So you'll notice here I have a boot image that I'm pointing to. So if we switch over to my Supermicro console here, I've already pre-created the NPod, but I haven't actually booted up to the Nebulon volume. So what I've done here is I've power cycled my server. I hit F11 to get into the boot menu, and you can see here my Nebulon boot volume shows up as the item that I've provisioned for it. I can hit enter, and so it can be very simple as rebooting a server to switch operating systems. I can go from provisioning a Kubernetes cluster to provisioning a VMware infrastructure and change those out based on the templates. And it's really as simple as just a server reboot to get the pod back up and running. And this momentarily will boot up to my Ubuntu operating system, and this guy will be ready to go here in a second. In the meantime, we will come back to that momentarily. If we switch over here to the servers tab, you can view detailed information about the pod that I've created. This is a single node pod for demonstration purposes. We recommend customers have at least three servers inside of a pod for high availability and redundancy purposes. We can see the volumes that we've provisioned, and the highlighting here the fact that this one here is my operating system volume. It's denoted by the _OS at the end, so it's easy to figure out which volume is related to your operating system. We can see snapshot related information. The nice part about this is we make it super simple. Over here on the right-hand side to, if you'll see the little two disks there, that's the clone operation. So I can come in here and I can say, you know what, I want to clone this volume, right? It'll show up under here under volumes, under as .clone. I've already pre-done this for us for the demo today. And then I can manage the volume exports as well. So I can quickly take a snapshot of a volume, and then I can present that snapshot, or I can control which servers inside of my pod have access to it. So there's many different use cases there, from a disaster recovery or software update use case. There's different use cases for perhaps I had ransomware that attacked a volume and all my data got encrypted and I want to quickly roll back. There's use cases for server operating system upgrades. There's many different reasons why you would want to roll back to different clones or snapshots inside of the environment. From a performance perspective, we can come into here. This one here isn't necessarily the greatest since we just booted that server up. So we'll go back over here to pod 3, click on metrics. We can quickly see, detailed performance information. We can change the aggregation from 1 hour to 6 hours. And we can scroll down here and we can see latency, we can see throughput. So it's very good detailed information that we can get back here within the user interface. The other cool item that I'll highlight, making this a completely software-driven approach, is we also have integration with webhooks as well. So if you utilize Microsoft Teams or Slack, for example, you can send webhooks and you can receive those. So it's easy to get alerts. We also support alerting via email also. And then the last tab over here on the right-hand side is VMware, the vCenter configuration that we added in. So that's basically how you cruise around the user interface there. And all I did was just bring back up over my console. We can see our Ubuntu server is fully booted up there, which is pretty cool. So let's get to the super interesting portion and huge differentiator of cloud-defined storage. With cloud-defined storage, all endpods are provisioned by using what we call application templates. Now, don't go run off and thinking, oh great, more YAML or JSON. They're very easy and UI driven. Alternatively, you can use our Python SDK or PowerShell module if you're like me and prefer scripting. Now, I am going to programmatically provision a full vSphere cluster, including ESXi, storage, networking, add to vCenter, and provision all of our data stores, all the way up to the point of my application or project team building their actual application on top of my VMware infrastructure. In this demo environment, I have 3 host servers which have just been plugged in, completely blank. There's no operating system installed at all on these boxes. No smoke and mirrors. To provision my vSphere cluster, I am going to apply a Nebulon configuration template. This template will provision and present boot volumes to my host using my pre-built vSphere operating system image. The template will also provision and present 2 terabyte volumes, which will be used as my VMware vSphere data stores. Cloud-defined storage ships with an extensive PowerShell module. The new neb npod commandlet will be used today to provision a 3-node vSphere cluster using the configuration template we just referenced a few seconds ago. The Bootstrap PowerShell script will reference the CSV file, which contains environmental information related to our build and can easily be populated dynamically. The remainder of the command contains specific npod details, which can too be populated dynamically. We're going to utilize our NebPower automation and PowerCLI PowerShell modules to complete our build out. So the first step here, we're going to import the modules. Then we need to check and make sure that the npod is able to be provisioned. Here we're submitting the request to Nebulon on and clustering together the 3 servers to form an npod, which are powered by Nebulon's scale-out IoT endpoint, which we call the Services Processing Unit. So if we zoom out, we can see that our pod has been built and we now have some storage volumes, LUNs, because cloud-defined storage presents block devices, but the operating system volumes do take a minute or 2 here to become available. This is because we're decompressing the operating system image and physically writing out the operating system to LUN 0 on each server. After completing the server, they will reboot using remote commands, which are issued to the ILO in this case. We've all seen servers boot, so I'll just speed things up from here. As the servers come up, we're going to set the host name, create VMFS data stores, configure networking, create vSwitches, set our root password, set up vMotion, and add our host to vCenter. Now with the host added to vCenter, let's cruise over to our data stores view and check out our cloud-defined storage volumes with all hosts in the cluster having access and the Nebulon IoT storage endpoint, the Services Processing Unit, backing the storage volumes. So if we cruise back over to Nebulon on, we can go under our npod and click on vCenter configuration. Here we'll enter in our read-only credentials for vCenter, and this allows Nebulon on to pull performance and telemetry data into the Nebulon on cloud. We'll give it our username, password, as well as fully qualified DNS name of our vCenter and hit update. Let's cruise back over to overview and we can change the card type to application here. And now we can see here within a matter of a few minutes, our performance information and virtual machine statistics will start to roll into the cloud, and you can view this detailed application performance information straight from Nebulon on. Now, guess what? We're ready to provision our applications. This is the art of the possible with cloud-defined storage. An agile product team could easily have access to banks of servers which are able to be provisioned and deprovisioned on demand as they wish, and they're able to integrate this directly with their application pipeline. Please throw your questions or comments in the QA panel and we'll get those answered. Nebulon brings a very unique and cloud-like spin to the server-based enterprise storage landscape. Cloud-defined storage separates the control and data plane. The control plane, Nebulon on, runs in the cloud while the data plane runs on premises within your application servers. If you're interested in kicking the tires, we'd love to get you going with what we call a VPOC. Or if you want to learn more about cloud-defined storage, please head over to Nebulon.com. And thank you so much for joining this VMUG virtual session today. We hope to see you next time. Thanks.